Alrighty, and last but not least, number 3. Let's give this a try. A bus company carries about 20,000 riders per day for a fare of 90 cents. That's pretty cheap. A survey indicates that each time the fare is decreased by 5 cents, the number of riders will increase by 2,000. What fare would result in the greatest revenue? Okay. Well, like I said in number 1, the first thing you want to do is look for the word each or every, and we find it right here. That's our let statement. Let n represent the number of, now, what are these doing each time? Each time the fare is decreased, we'll worry about the decrease, what the word decrease means in the equation, but this is what we're interested in. For each 5 cent that it's decreased, something happens to the ridership. So let's see. Let n represent the number of 5 cent decreases. Okay. Let's start with revenue function again. Revenue equals price times number sold. Okay, I'm going to just short form that R. And because the variable I chose to use is n, I'll make function notation R at n. All right, current price. Start with that, 90 cents. We are decreasing the price by 5 cents or 10 cents or 15 cents and so on. So decreasing the price means minus 5 cents times some number of multiples of 5 cents. Okay, now for the number sold. How many do we already sell? 20,000. But if we decrease the price, the ridership increases. So increase means plus, and we get 2,000 more riders every time we reduce the price by a nickel. So n and n. There you go. It's asking us what fare would result in the greatest revenue. Well, again, greatest means maximum. Would this parabola have a maximum? Can't really tell until we get into a form that we recognize. So let's expand. 90 times 20,000. That's my first times first. Outsides, 90 times positive 2,000 n. It's 180,000 n. Insides are these two, negative times positive, I should say, is negative, and 5 times 20,000 is 100,000 n. And then my last negative times positive is a negative. 5 times 2,000 is 10,000, and n times n is n squared. These two are like terms. So let me clean this up a little bit. And also I want to put my n squared term first. So I'll put negative 10,000 n squared. I'll combine these two. 180,000 minus 100,000 is 80,000. And then I'll put this one last, positive 1,800,000. Okay, so we need the vertex. Does this open down? Yes, it does. So it will have a maximum. Excellent, because they're asking us for the maximum. The greatest revenue is the maximum revenue. Want to complete the square, or do you want to use the shortcut? I think you want to use the shortcut. Negative b over 2a. What is behaving like the b? Here's a, here's b, here's c. This is standard form now. Ax squared plus bx plus c. All right, so 80,000 is behaving like the b. So negative 80,000 over 2 times the A value, which is negative 10,000. Punch that into your calculator, you will get positive 4. Okay. The vertex here, which is normally H comma K, in our case is going to be N comma R. N is behaving like X, and H is the X coordinate of the vertex. R at N is behaving like Y, and K is the Y coordinate of the vertex. So if we're looking for the fare that would result in the greatest revenue, then we need to take this 4 and put it back into the price function, which is 90 cents minus 5 times N. Well, now we know that N is 4. That means we want to reduce this price by 5 cents 4 times. 5 cents 4 times is 20 cents. Oops, that should be 70 cents. There you go. Done.